If you have access to a large format CNC machine, say something that is a 4x8 sheet of plywood, or you have a large format CNC machine, again, something that does say a 4x8 sheet of plywood, eventually somebody's going to ask you to make something big.
Hey babe, I think we need a big table in here.
Like that. Luckily for us, there's Opendesk.cc, and they allow you to download furniture designs that get built on 4x8 sheets of plywood. Mix that with a little Fusion 360 CAD CAM and you can make furniture on your CNC machine. So, let's do that. If you've never been to Opendesk.cc, let me introduce you to it. Opendesk.cc is essentially like a distributed marketplace where designers create furniture designs that can be built with plywood, usually pretty good birch plywood in European sizes. So they measure things in millimeters, so it's 18 millimeter instead of 3/4 inch, or 24 millimeter instead of 1 inch. Thickness material. The 4x8 plywood is still standard. Their sizes are obviously in millimeters, but it's still 4x8 at the end of the day. So that's not an issue, but your thicknesses are going to be an issue when you're trying to make this stuff. Anyway, so designers design it, and then they have a whole marketplace of makers. And so as a consumer, somebody can show up to this website and decide, hey, I want a whatever piece of furniture. They have a whole library of furniture here, and you can come to this and say, hey, I want this piece of furniture, whatever it is. The great thing is that for those of us that have CNC machines, maybe we don't want somebody to make it for us. Maybe we want to become a maker for them, but all these designs are downloadable for free. So you can download these designs and you can make stuff for yourself, private use stuff. And then if you become really good at making stuff, you can become potentially a maker, and people would potentially buy this stuff from you, and the designers would get a cut, and Opendesk would get a cut, and it's all based off you. Like, you figure out what your price is, and then they tack on fees on top of it. So I've personally made the breakout table, which is kind of what led me to this video, and I'm going to make the layout table. I'm going to actually turn it into a coffee table. I think it's going to be a really cool coffee table. But for kind of talking through how you do this, we're going to use the studio desk for this. So, you know, the site is focused on makers and buyers, right? So when I come to this, it's going to really focus on, you know, selling me this design that I want somebody to make it for me. It's going to like nice website, and let me zoom in and see some stuff. And well, actually, I want you to note that that angle there. That's actually going to play into when we talk about how we make these things. And with the default view is going to be like, hey, it's $508. Well, that $508 is what they estimate the price would be if I were to request a quote. So what would happen is if I click request quote, it would ask based off where I live. I happen to live in Austin, Texas, so it would probably send a notification out to any of the makers in their network in Austin, San Antonio, Houston, or Dallas saying, hey, this guy wants this table. There's also here, if you notice, a download link. And this is where, if you're following along, you probably have a router that supports 4x8 sheets of plywood, or you have access to one. What I have, I mean, I don't have a mill yet, so maybe if I have a mill and you're watching this later, then right now I've focused on these things. Downloading lets you download the DFX and make this yourself. And when you make it yourself, you can make it, again, for private use. So for yourself, for your office, whatever. You just can't sell whatever you make. Click on continue to download. Takes you to a page basically reminding you of the licensing and saying, hey, you're downloading a digital file and you have to understand how that file works. And you need access to a CNC machine if you don't have one. You give them some basic information. You promise that you acknowledge that you're making it and they're not responsible if the design doesn't work, because you're making it on your own. You're not buying somebody's expertise to make it. You click through all of that, and it takes you to a download page. Now, the download page is pretty straightforward, right? You can eventually share your build, like, hey, look what I built. But the download page initially, shows you the DFX file and the assembly guide, which I jokingly call the IKEA guide. There's a DFX file per sheet of plywood necessary to make something. So if something's really, really big, it takes 3 or 4 sheets of plywood, there'll be 4 separate DFX files. Now, their code here, I can't decipher this code except for 2 things. I can tell you that CAD-1 gets to CAD-2, CAD-3, CAD-4, the multiple sheets if you have multiple sheets of plywood. And the 18.00 is the thickness of plywood that they have designed this file for. So this particular file is designed for 18 millimeter plywood. When I did the desk, it was designed for 18 millimeter plywood. I used 18.2 millimeter plywood, and I just had to hit things with the hammer a little harder to get everything to stick together. Obviously, if you did say 3/4, I think it's slightly less than 18 millimeter, and so things might be loose. And if you really wanted to go 3/4 and use their designs, you would probably need to go through and look at all of the all of the mortises and tweak their sizes and any tenons and tweak those sizes to fit a 3/4 inch piece of plywood. But you want to know that because there are designs that use 12 millimeter, there are designs that use 24 millimeter. So depending on your design, you want to know what material you will need to buy. Once you download that, I would just downloads everything as a zip file. I keep my zip files in a folder called Opendesk, and in this folder is everything that I've downloaded and worked on really so far. Not 100% of everything, but most everything, or am working on. So here's that studio desk or whatever, and here's what you open up. What you get here is you get the assembly guide, which we'll pop up and look at in a second. You get that DFX we talked about. You get a test cut sheet, which you can kind of use to make sure that your router will do what you think it'll do. Then you have two documents that essentially say the same thing. You have your licensing document that says, hey, this is a Creative Commons non-commercial use. So use it for yourself, use it for your office. You can't sell it, right? And then this other document is hey, if you had fun making this, you should join our maker network and become a maker, which, hey, maybe that's if you like doing woodworking and want to find a new way to make some money, then this might be an option for you, and awesome. And obviously the DFX. So let's talk about the DFX. What you're going to do is you want to pull that into Fusion 360, however you want to pull it in, and it's going to come in, it's going to look like this. So this is what it's going to look like. Now, the naming convention is top, bottom, and then this is combined. And obviously in this case, if you look, you're like, well, the bottom doesn't show anything. That's empty. Not all designs have bottom. And I'm gonna call it top and bottom, but let's also be clear. The top and bottom don't necessarily mean the bottom and the top of the job. So, for instance, all of the layers in the section highlighted in blue are marked top in their name. However, they are in fact the bottom of the desk. So while they say top and bottom, you do have to be careful about what they actually mean. So what does one look like when there is a top and a bottom? Well, let me show you that. So here's what a design looks like when there's a top and a bottom. So there's a top, there's a bottom, and there's everything. Now the funny thing is, the top, if I'm not mistaken, is actually the bottom of the piece of furniture. So that's the underside of the furniture, because these, if we knew what we were looking at here, these are pockets that are being cut out of these brackets, and they're slide-in drawers. So those pockets are obviously going to be, that's the top, right? We'd be looking down at those pockets when the part is completed, and that's a little confusing. And you can see it's designed so you can actually just CAD out 2 sheets of plywood. So I can CAD out sheet 1, and I can CAD out sheet 2. I can do my CAM for sheet 1, and as long as I leave my origin in the same corner, and I literally just flip the sheet of plywood over on its axis, the long axis, then the origin stays the same, and I cut again, and it cuts right in the right spot. And you can see that because if you look, these are slightly off center from these, right? So these guys are kind of to the right, and these guys are kind of to the left. And if you think about it, they're really lined up. And then you have this overview, which kind of shows you how everything should lay out when it's all actually cut. I usually don't use the overview at all. Really, top, bottom is what I care about. Now, when I say top and bottom, if I look at the sketches, they call it reverse and top. So they changed the language, reverse and top. The point is that this is the reverse or bottom of the cut, but it's not actually the bottom of the piece of furniture. So you have to be careful about their language. Let's get back to the one we're going to do, which doesn't have a reverse. So we just, in theory, if you were to make this, you wouldn't have to flip your plywood over. You could put it down once, clamp it down, not worry about registering it, and cut it out, and you'd be good to go. So we have this document. Now, there's a couple of things these documents have by default. They have this kind of set of borders sketches, and I tend to just turn all of them off when I'm working. I'll come back and I'll use this nominal border in a second, but when I'm doing my initial working, I'm just going to turn it off. I don't want that sketch in my way. Let's go ahead and just close this panel real quick so we have a little more room. So here we have ostensibly the same drawing twice. We're going to ignore the drawing over here, which is our overview or final cuts drawing. We're going to focus on our top. And there is no bottom or reverse cuts, so we can ignore that. Now, real quick, let's break down how the layers, because the layers describe what to do. So the top and reverse is where to do it, and then the rest of the description is what to do. So you have top, pocket, inside, 1 millimeter. So what it's saying is for everything in that layer, for all of everything in that sketch, if I were to look at the items in that sketch, and there they are, it wants me to pocket the inside, so obviously inside that circle, 1 millimeter deep. Awesome. Now if we look at this again from, say, this one, it says hole 9 millimeter diameter, 13 point blah blah blah, and we can't see. So if we mouse over it, we get the whole detail. Top hole 9 millimeter diameter, 13 millimeter. So what it's telling me is it wants a 9 millimeter diameter hole, 13 millimeters deep. So if we were to double click on this guy and we go in and look here, here's this hole, and we can confirm that we think we want a 9 millimeter hole because we can inspect that, and lo and behold, it's a 9 millimeter hole. So they want a 9 millimeter hole, 13 millimeters deep there. All right, so you're kind of getting an idea how this works. If you pocket inside here, same kind of thing. Let's find a more unique. So here's a top cut inside. So it's basically saying, hey, get rid of the inside, however you want to get rid of it, clear it, whatever. Cut, pocket, same kind of thing. I think cut, what they mean with cut is when you go all the way through the material. So, but you can gather that information because it's 18 millimeters and it's an 18 millimeter piece of material. So you understand cut inside and pocket inside. If you said pocket 18 millimeters, it's the same thing as cut 18 millimeters. But you do get things like pocket inside 12 millimeters, where they just want you to kind of, actually all they really want you to do is shave away material kind of over here in this shape. You get the same kind of thing over here. If we look, we're going to find a pocket inside 9, and you see here they want you to cut away 9 millimeters of material in a couple of spots here and here. So, and a couple of spots here, a couple of spots here, a couple of spots here. So they've got a bunch of places they want you to cut 9 millimeters away. So how do you process this file? What I do is I turn this into a 3D model, and it's actually pretty easy. What I look for is the most important step, which is to turn everything into a 3D model. And that is, if we look through this, we will find a cut outside. And there's probably only 1 or 2 of these. These are going to make the 3D model. These are going to make your primary shapes, right? Cut outside 18 millimeters. So theoretically, everything in blue is actually inside, right? Everything outside it is waste material. So we're gonna double click on him, and then we're just gonna select everything on the model, on the sketch. The sketch side we're gonna use. Then we're just gonna right click. Let me actually do that. Yeah, that's fine. Didn't actually mean to do that. So sorry, right click. I meant to go to extrude, not create selection set. So right click, extrude. And now here's where I think is the novel approach that I take. I want to go negative 18 millimeters. Because what I'm going to do is now that I have my bodies, I'm going to systematically go through and I am going to subtract material. So I'm going to cut material by doing the extrusion. So I'll select some stuff, extrude, negative direction. It will automatically know that's a cut from the material. So it's actually, Fusion's pretty smart. And also, because I've already done this one, it goes ahead and Fusion no longer shows it. I mean, I can turn it back on, but it by default hides it. So now I can know which ones I've processed. So we can just go down the line, and I can double click on a particular sketch, and I can make sure to select everything in that sketch, and then right click, extrude, and by default it wants to make a new body. But if I say -1, because that's what it wants, top pocket inside -1 millimeter, it immediately goes to a cut. Super. And now it hides that one. I can go to the next one, and same thing, double click on it to start working on that sketch, select everything in that sketch. If I want to make sure I get everything, do it again, right click, extrude, and it wants to make a new body, except if I go -9, it's going to subtract by 9 millimeters. And again, we keep removing material. Now, let me make this visual style. If you do visual edges only, you can see the material kind of coming together. 6mm holes. Now, we're not going to dive too deeply into the cam side of this, frankly, because if you're at the point that you're considering making one of these, the cam in this is going to be really simple. So we'll just touch on it briefly. I'm not going to walk through the cam. I don't want to spend that much time with you guys. It's not a good use of your time. But with these 6mm holes, you'll see there's a bunch of them here. And what I have found is these are, at least on all the designs I've worked with and looked through, these are for dowel pins to glue stuff together, to register it and then glue stuff together. So for those of you in the States like me, don't worry about getting a 6mm bit. Do a drill operation with your 1/4" bit and go get 1/4" dowel pins, whatever, inserts. That's what you're going to use. This is 15mm long. 30mm long is what they want because they usually cut 15mm deep. But you can find that. That's easy material to find, and you can just use your 1/4" bit. So you don't have to worry about, oh my gosh, 6mm and have to go get a new end mill. Just use your 1/4" end mills. You'll be fine. All of the dog boning and everything is designed to fit a minimum of a 1/4" end mill. But these drill holes, they do 6mm because they assume in the States we're going to drill with a 1/4, and in countries that are not on the imperial unit because they're, I won't say smarter than the States, but let's say smarter than the States. I'm going to go with it. Those states that are not on the imperial unit, they're going to have 6mm end mills instead of 1/4" end mills. Right. That being said, same bat plan. We're going to click on everything. We're going to select everything. Once we know we've selected everything, we're going to right click, extrude, negative, and the distance we want to go, if we mouse over it, is 15mm. So negative 15, and okay. And again, we're just going to follow this process. So I'm just going to click through these. I'm going to speed up the video here for a bit, and then we're going to talk about the CAD. We'll use another graphic, but I want to show you what the finished model looks like before we do that. So that is done, and if we turn off all the sketches for a second and we go to a nice pretty home, you can see there is everything you're cutting. And once you're done cutting, this is what you'll have. Now we're gonna talk briefly about the cam. We're gonna use a different model to go through the cam, but you might have noticed I did not touch the Chamfer. So let's talk about that real quick. Chamfer's a little unique, and they don't give you exact specifications for it. They do want you to run a chamfering bit on exactly that line. So if you have a V-bit, they're talking about a V-bit when they say chamfering. If you have a V-bit, they want the V-bit to run exactly on that line. Easy enough. You can do a V-bit and put it on a path, and they want that path to be 14mm down. So what happens is they've kind of pre-planned a little bit. Their estimation is 14mm down here. It's going to do just the right amount of cutting off of the knocking off corners. To be honest, I'm not sure why they're knocking off those corners, but they are because they're inside corners. But they're asking for it. Until I build this one, I couldn't tell you what the logic is there. And then they want to do a chamfer on the actual tabletop itself. Remember I mentioned take a good look at the tabletop, because if we look at that tabletop, if you look really carefully right here, you'll see there's that 14mm chamfer. It looks like a 45 degree, so a 90 degree bit, but that could be a 60 degree bit. That could be a whatever bit. I can't really tell you what bit it is. I just don't know. Could be a 90, could be a 120, could be a 60. They don't actually tell you either. So a little bit of ambiguity on what they want you to do there, but what they do want you to do is to program into your cam take a chamfering bit and drop it 14 millimeters and make sure it's wide enough to touch the material. So, right, if we're looking here, and we measure, say, here to here. Does it let me do that? It's not going to let me measure that. Anyways, whatever that distance is, they want it to be obviously at least that wide. And 14 millimeters down. And obviously you can be wider than that. You just got to make sure it's that wide. And then here they want it to be 14 millimeters down because they're going to do a true chamfering off of that size. So that's what the chamfering step does. That's why we don't actually put it in the model, because if there's one thing I've learned, don't put chamfering in your models. Let the CAM chamfer for you. Just tell it the paths you want it to chamfer, and it will. Unless there's some reason you have a specific chamfering shape that you absolutely need in your model. Just the one thing I would add, hey, if Opendesk, if you're watching this, have everybody add a chamfering angle that they want there. So I think that's silly not to have it, but so I would say that's a missing thing that needs to be there. Add that angle. Right. So I'm not going to go through the CAM on this one. What we're going to do is we're going to look at another one I've done, same process, and we're going to look at the CAM on that one, because I think it's a better use of everybody's time. So let's just open up this file here. Same process, actually slightly 99% the same process. I ended up tweaking this design a little bit, so I removed some parts that I ended up not needing. So the design's a little different, but it's 99-ish% the same. So the result is the same, right? I got to this point where I have pockets and shapes that I need to cut out. So let's jump over to the CAM. And in this case, I had suppressed these because I think when I was actually running the job, I had to stop it overnight and whatever. I didn't want to repost the whole job. Challenges of a garage CNC machine, right? So let's just generate those tool paths. All right. So what I like to do is my drilling operations first, then all my adaptives. Then I like to clean up my adaptives with contours. And then when I'm done cleaning up my adaptives with contours, I want to cut all the parts out. And I might do that in 2 or 3 operations in here. So let's just kind of step over these, right? So we're gonna go through, and this is what I was talking about. Just use a drill. If we look at this, it's 1/4-inch tool. I'm running in the drill hole. I'm doing drap it out. I think I would next time do chip breaking, because our end mills can get a little burned just being used as drills. So I would probably do that chip breaking, partial retract, just to kind of clear the hole as we're going. Maybe not. It's up to you. Then I got all the adaptives that were kind of pockety and in stuff. You can see all those getting hit. I had a couple spots that didn't want to play nice with the other adaptives. It looks like that spot didn't want to play nice with the other adaptives, so it got to be its own operation. Then I went through and contoured everything that I hit with the adaptive to clean up those edges, because an adaptive does not leave you clean edges. It can leave you little bark marks and stuff, because that's not its job. Its job is to clear. And then I started cutting out the parts, and the more parts cut out, and then finish cutting out the parts. It really is straightforward. Obviously, when I'm cutting the parts, you notice there are hold downs. I don't like, I don't know why, but I don't like the default hold down locations most of the time. So when I do geometry, I must have done by side. I play with this a lot. Whenever you're sitting here and you're like, well, is that the right spot for those? And you play with it and get it right. Half the time I end up just, instead of going by distance at point, and then going and literally putting the points in that I want. So that's what I do there. Now, with my setup, I mentioned that I'll leave that one thing open. Let's go back to this guy. So one thing I forgot to mention. I'll go back and I will take this board here, and I will go ahead and extrude him -18, not 117, -18 millimeters, and I will do him as a new body. So why am I doing a new body, -18 millimeters? Well, one, that body ends up being right with everything else, which is nice. But why is it nice? Because what I'm going to do when I do my CAM, and I should do it over here real quick. When I do a setup, I'm going to take that setup, I'm going to go stock, and I'm going to go, from solid, and I'm just going to go ahead and grab that material. Say, there we go. That's my my setup. Move my origin obviously and stuff like that. Right, so that's how that's all. I hope you found that useful. I won't leave you guys high and dry. Little clip of me kind of cutting and putting this together. The footage wasn't great, which is why I didn't do like a build video. But I wanted to go through how you actually process their files, because I think understanding how to process their files is going to open up a really great library of stuff you can make for yourself. And then, hey, maybe you become a maker for them and you make stuff for them, and that's awesome too. Anyways, talk to you at the end of the montage. So the CAD CAM wasn't too bad, and Opendesk has lots of designs. So after you cut out a bunch of stuff and sand and sand and sand, you can put together a nice piece of furniture yourself. And you never know what projects you're gonna get.
Hey babe, we need a coffee table.
Like that. Anyways, while I'm working on a coffee table, please subscribe or comment below, and look forward to sharing my next video. Thanks all.